So I have here a 540 kilogram dragster's tires accelerated from rest. You know what? That's an important word. What does from rest tell me? VI is what? Also, as soon as they give me VI as 0, James, I'm thinking maybe I'm going to find the acceleration using VI, VF, T, and D, not using F equals MA, A equals F over M. You see how that's a little bit of a hint there as well? From rest to a speed of 32 meters per second in a distance of 64 meters. Okay. James, what does part A want me to find? So part A wants me to find A. You'd think I planned that. James, my friend, what else do I know? VI is 0. And now my path is set. In other words, even though they gave me the mass, I didn't start, James, trying to go like this. And the reason is also, I read B. Can you read to me what B wants me to find? You know what? If they want me to find the force, I don't think I can use the force to find the acceleration in part A. You okay with that, Hayden? In other words, get in the habit of reading the whole question. Use hints, because there are going to be clues as to which approach to use. So, James, I agree. You said VI was 0. James, what else do I know, my friend? VF is 32. Pause the video as one of my latelings comes in here. And I need to rewrite that 32 because that looked yucky. What else do I know? Okay. Positive 64 or negative 64? Are you positive? Yeah, forward, yeah? Okay. Hey, is there an equation that has those in it? Yeah. Which one? James, my friend. Okay, hey, can you get the D by... You're right, it's the VF squared equals VI squared plus 2AD. Can you get the D by itself? Sorry, can you get the A? Whoops, can you get the A by itself? Knock me out. Okay, the equation is... I don't mind. This. By the way, again, if I haven't said so, Cam, I'll repeat myself. Everything from that unit is going to be fair game here too, right? Because acceleration overlaps for both. So, James, I'll write it out. VF squared equals VI squared plus 2AD. You have it in front of you on your sheet. Yes, James, my friend? Okay, there's the A. There's the A. See it, see it, see it, see it? What's going to drop down like a domino? The other side. I got to be fussy. The VF. Okay. Then what? How would I move the 2D over? Not the 2AD. I want the A to stay where it is, right? So I'm going to move everything. How would I move the 2D over? Why? You're right. Because what's the 2 and the D doing to the A right now? Okay. What about the VI squared? How would I move that one over? Which one will I do first? Because it's reverse bed mass, right? So if I hear you, you're telling me minus, yes? And then you said what? Ah, thank you. I know it's first, and I'm going to put the A on that side if that's okay. I know it's first thing in the morning, but I knew you could handle it. And I gave us a whole page. Yeah, I did. Good, 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 good. It's going to be 32 squared minus 0 squared all over 2 times 64. Yes? I think, you know what? I think I could do this in my head because 32 squared is really 32 times 32, and 64 is really 2 times 32. So one of the 32s is going to, you know what? Correct me if I'm wrong. Do you get that? Is it 8? Yeah? Yeah, I saw that 6. Nice try. And don't say bad words when I catch you for being late, Chief. People on YouTube are going, say what? I have my students roll a big dice and we multiply by 5 when they're late. That's their detention, and someone just rolled a 6. Same notes from last day, Ty, so we're just continuing on from where we were. Oh, no chair for you? That was mean of me. Is it, by the way, is it 8? Yes? Okay. Probably a little small. I'm thinking a dragster might accelerate at more than 1 G, but maybe not. You okay with that so far? Luke, what are they asking me to find in part B?
The net force.
Did you say net force? That's my little hint for you to say, look, don't worry about a free body diagram. We might need one later, but the net force is just plain old MA. F net is MA. Do I know the mass?
Yep.
Do I know the acceleration, James? Oh, that's why we had to do part A first, okay? Now, I would have no problem in your homework giving you this question, but not walking you through part A and part B, just jumping straight to part D, as a matter of fact. But let's walk through it. So it's going to be 540 times 8. Can I do that in my head? Well, it's going to be 1,080, and then times 4. 4,320? Yeah? It is possible to do math first thing in the morning. Luke, 4,320 what? Yeah. Okay. Hayden, what does C want me to find? Friction equals what times what?
Mu times.
I knew I could count it. Nu times the? Yeah, that. Oh, you know what? I think now I better do a free body diagram, because have they mentioned or have they given me the normal force or anything? You know what? How about over here? Here's my dragster. Hayden, I want you to imagine that you are behind the wheel of a dragster. You got your helmet on, you got your goggles on, you're giving it some, you're hitting it, the Christmas tree has gone green, you floor one of the forces acting on the car. Get the obvious one. Yep. What else? Oh, he yawns and thinks about it at the same time. Is the car sinking into the ground like quicksand?
No.
Is it flying into you like Superman?
No.
So there must be another force canceling out gravity, pointing which way? Up. Same size as gravity? I think so, because the question doesn't seem to have mentioned any other vertical forces. What do we call this here force here that the ground exerts pushing back up?
The normal force.
I knew I could count on you. What else? Hayden, is this car accelerating?
Yeah.
Which way? You know what? Let's just decide. If the question doesn't say, let's get in the habit of having it accelerate to the right, like in the positive x direction on the graph, and that way just all our pictures look the same hand. It's not a rule, but let's just do that. So let's have it accelerate. So if it's accelerating to the right, there has to be a force that way. Yes?
Yeah.
So here's the $1,000,000 question, folks. Which force is that? Ethan, what was that? Are you saying that if this car was on ice, this wouldn't work? Yeah. This is kind of weird, because in our previous diagrams, friction has always been slowing us down, right? In other words, here, friction was pointing to the left. Here, friction was pointing to the left and to the left. But here, for a car speeding up, friction is pointing to the right. Is there anything slowing it down? Technically air resistance, but we're going to ignore that, because I said we were always going to ignore it unless the question specifically mentions it. Is that okay, Hayden?
Yeah.
Okay, so you just told me that friction equals mu times the normal force. Do I know the normal force? Well, no. But look. I know another force the same size as the normal force. What? Okay. Do I know mu? Hey, Luke, what did I find in part B? On my free body, which was 4,320? On my free body diagram, where would that 4,320 show up?
To the left. Pointing to the left.
Slowing it down?
Oh no.
I think I can be even more specific. Folks, if that's how fast the car is accelerating, isn't that actually, because what force is accelerating the car? So isn't friction what's making the car accelerate? Isn't friction, although Hayden, you are right, friction is mu times the normal force. I think in this case, I can actually just say, in this case, who's winning? Who's losing? It's a trick question. Shaking your head means. So you would say winner equals. You see it, Braden? So although I was all set to go friction equals mu times the normal force, and by the way, the reason I knew I had to do something like this, Cam, is have they given me mu, the coefficient of friction? Say no. So I better try something else. So it turns out friction is 4,320 newtons. Is that okay, Mason? Mason, what does part D want me to find? Please read very carefully. I don't think so, because I think that's what part C wanted me to find. And I don't think I'd ask you the same question. What? The whole phrase, please. That's okay. That's the magic 3-word phrase. So you ready? Yeah. Scene 1, act 1, take 2, and action. Mason, my friend, clever boy, what does part D want me to find? Oh, you are ever so clever, Mason. I knew you could come through for me. What is the coefficient of friction as a symbol? Mu. What's mu? I don't know. What's mu with you? Are you saying this question's asking me to find mu? We have an equation with mu in it. Hayden, what was the equation with mu in it that you quoted me a few minutes ago? That I... Let's go black. Friction equals mu. Right, Mason? Right. What did you say it's asking me to find? Coefficient of friction. Which is what in this equation? Which is... What symbol in this equation? What variable in this equation? Yes? Yes. See the mu? That funky thing right there? See it, see it, see it, see it, see it? Yeah. How would I get that by itself? Divide that down. Nice. So if I hear you correctly, and I think I do, you're telling me that? Yes. Okay. Do I know friction? The force of friction? Yeah. How big? Yes. Oh, Mason, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. On my free body diagram, which force must be the same size as the normal force? It's going to be 4,320. Did they tell me the mass? Yeah. What? Do I know G? Yeah. 9.8? Yeah. What's the coefficient of friction between these tires and the road? How sticky are these tires? Let's find out. 4,320 divided by bracket 540 times 9.8. 0.816. These are pretty good tires. Actually, for dragster tires, they're not. Dragster tires, you'd want to be even stickier. But 0.816? 0.816 what? What were the units for the coefficient of friction? There are none. Okay? Is that okay? So if you were a tire company, a dragster tire company, and you wanted to advertise your tires and how sticky they were, this is the test that you could do. You throw them on a drag, you get the weight, the mass of your dragster, have it drive on the road, and then you could reverse engineer. If you knew the acceleration, you'd get that from a stopwatch, timing it, getting the speeds from the speedometer. You could then reverse engineer and say, this is how sticky our tires are. How can we make them stickier? Because we want a bigger traction, more friction, more acceleration. Is that okay? Yeah. Is that all right? Yeah? It's complicated stuff here. Example 9. I think this is the last one. It is. Example 9 says, find the net acceleration of the mass below. Find the acceleration of the mass below. Is there a picture here, Braden? Has it got forces on it? You know what? Let's continue, let's put the rest of the forces on here. Instead of drawing a separate free body diagram, let's just label them right on here. Kareem, my friend, what are the forces acting on this box? Get the obvious one. What else? By the way, you'll notice I'm giving you fewer clues and fewer hints to fill these out. So I used to say things like, is it sinking? I'm just saying, what else? Bigger, look carefully, bigger, smaller, or the same size as gravity? Cam. With authority in his voice, much like he shot his hand up when we voted last day. He knows his stuff. Don't let the looks fool you. He knows his stuff. Why smaller, Cam? 25 newtons up is taking care of some of gravity. The normal force is going to be smaller because everything up is canceled out by everything down, but there's already something up canceling out some down. Which, by the way, means friction is going to be less, because I've told you this is why when you lift up as you slide something, it's easier to slide it. Is that okay, Kareem? What else? Here is my applied force. I snuck that term in the other day, right? That's what we're pulling with. Luke used that term earlier today. What else? Is there friction in this question? Say yes. Say yes. How do you know instantly that there's friction in this question? What's mu? I don't know. What's mu with you? Okay, that'll be my way of telling you include friction. Okay. If I don't put a mu and the question doesn't mention friction, we'll just assume we're on ice. Or sometimes I'll even say mu equals 0. That's my way of saying pretend we're on ice. Although now that we've learned friction, I'll almost always include it in because it's the real world. Which way would friction be acting? Which way will I draw my friction arrow pointing? You're right, how do you know? Which way do you think this thing is sliding? To the right. And so if you're sliding something to the right, which way does friction act? To the left. And I'll draw it shorter because I'm pretty sure the 45 is winning. I think. You with me so far, Kareem? Hey, what's this question asked me to find, Kareem? You know what? I really think I need to write an equation. Who's winning? So just to jog your memory, I'm going to go winner minus loser equals F net. Because, by the way, as soon as it said net acceleration, I said, oh, it probably wants the acceleration from the net force. And that was also a trigger. I better go winner minus loser. Vertically, it's a tie. Horizontally, who's winning? Who's losing? What does that equal? Yeah? Okay. How would I get the A by itself? Because that's what I want you to find. So if I hear you, you're telling me yes? Okay. In your homework, you might start to take a couple of shortcuts if you get good. I'm going to write every step in our notes so we know what the heck we did. So on the next line, I would say A equals F applied minus, Hayden, friction is what times what? Okay. Right? I don't know the normal force. Oh, but look. Eesh, I can figure out the normal force. So you ready? I'm going to go equals F applied minus mu. There's more than one vertical force going on here, Mason, so I'm going to have to be a lot more careful. My normal force is different, and it's going to be over M. Kareem, my friend, how big is the normal force? Now, before you answer it, you may, if you need to, jot down everything up, don't write this down, equals everything down. You may say everything up normal force and that 25 equals everything down. You okay with that? Can you tell me how to get the normal force by itself from that little equation there? How would I get the Fn by itself here? You're way overcomplicating this. Read this to me. What does it say? Fn. Sorry, what did you say? Fn what? How would I get the Fn by itself then? Yes. Okay? Yeah? In other words, how big is the normal force? mg. Loud and proud. How big is the normal force? mg. Okay. By the way, if this was pointing down, I think it would be mg plus 25, but I don't memorize that. I just really quickly write this equation and figure it out. So if I hear you correctly, what did you say the normal force was? mg. There's my equation. You okay with that, Takato? Kareem, do I know the applied force? Do I know mu? Do I know m? G, 9.8. Do I know, you know what? Do I know every single variable? Then I can plug and chug now. Here we go. Let's get the answer. The acceleration, how big was the applied force, Kareem? Minus, what's mu? 0.36, thank you. What was the mass? Times 9.8 minus 25 all over, you said 5.8 kilograms? Okay. Is this a fraction? Is there more than one thing on the top? Okay, so I'm going to go bracket 45 take away 0.36, and I guess I'm going to go bracket again. 5.8 times 9.8 minus 25. Close off that bracket. Close off the top. Divided by 5.8. Yeah. I got 5.78 meters per second squared. Yeah. Derek, you okay with that? What else, Derek, could I do? Now that I have this, I would have no problem as a next step saying, oh, if VI is 0 and it travels for 30 seconds, find V final. Or find distance, how far it traveled. In other words, James, now that I have the acceleration, all of the stuff from before Christmas, totally fair game. Okay? And I start doing some of that in the homework. So speaking of homework, what is your homework? I already assigned 1, 2, and 3. You can now do 5. I'm going to assign most of this. 6. 7 looks very similar to the question that we just did, although in this case, I think the 12 is pushing down instead of the 25 pushing up. You might have to tweak it a little bit. 8, elevator question. 9 is just asking you to find the normal force. Good free body diagram. 10, hey, tension, this is not friction. This is a nice review of what we've been doing so far. Number 11 is saying find what's mu. I don't know what's mu with you. 12, little race car question. Yeah, I'm going to assign all of it, and we'll even let Connor and Liam be astronauts. Connor and Liam are astronauts working in weightlessness on the ISS. Connor takes a box of mass 45 kilograms, and he pushes it towards Liam at 2.2 meters per second. So you can imagine the box floating across the space station. Liam decides to stop the box with his face. Will it hurt? That's really the question I want to ask. Would it hurt in weightlessness to get hit by a mass? Or if you really want to be poetic, could you have a boxing match in zero gravity? Would punches hurt at all? Or because nobody has any weight, would the punches not do anything? We'll talk about that next class. I'm going to give you some time to work on this in a bit, but we have a video to watch.